So guys, we have done with the static route, right? And what is the static route? We can define the static route in the two ways. First of all, the IP route. This is the command, and then we have to say that network ID. Then we are going to say that submit mask information for this guy, and then we have a next stop information, right? And the another base is the IP route. Then we have a network ID, and then we have a submit mask information, and then we have a exit interface. So this command is only required for the point-to-point network if you are going to running with the serial link, right? So what's the difference between this command and this command? The first of all, the first command, in this command, what happened? The ARP will generate it for the next stop information, right? ARP will generate for this guy. And in the second command, the ARP will generate for the this guy. So if you have a R1 and that has the thousands of the information behind the ISP, right? And you have give the thousands of the route by using the next stop information, that is the exit, sorry, by using this command, exit interface, then you have a thousands of the ARP entry on your routing table of, in the ARP table of R1, okay? But at the same time, if you're going to use the first command, next stop information, and you have give the thousands of the static route towards the ISP, then you have a single ARP information only for this guy 12 or 2, right? This is a difference between this guy. So we are not going to use this thing in the market right now because it will take the so much process on the router, right? And even the router is not only going to maintain the ARP entry, they have another process as well as, right? So this is not a good thing. That's where always we are going to prefer this guy, okay? Then after that we have seen like if you make the AD of 255 or the static route, the router is not going to install that information in the routing table because this AD is known as a unknown route. Okay, so if you have any route, for example, I said the IP route, adjust a default route towards the ISP 0.0.0 and 0.0.0, and if I'm going to put the next stop information 192.168.12.2, and if I'm going to make the AD of 255, this route will be removed from your routing table. Okay, this route will be enabled install in the routing table. If I'm going to give the 254, then router will install this route in my routing table. Clear? Now, after that, we have also seen like what is the use of floating static route. Floating static route is something like to give the backup path to the ISP, right? So by default, router is going to only maintain the best path. So I just give the one route has the AD of the by default one is there. I'll just make the another guy has the AD is a 10. So it will install this guy, not this guy. So once this guy goes down, this ups. Okay, once this guy comes up, this goes down. This is the floating static route we have. Now, but the thing is that if I'm going to talk about the disadvantage of the static, what is the disadvantage of the static route? Disadvantage of the static route. If I'm going to compare with the disadvantage of the static route, it's something like that. For example, this is my router number 1. I'm just going to recap. This is the previous last classes of the thing, whatever the disadvantage. And for example, this is the ISP of this guy. We have a connectivity with the ISP, and behind the ISP we have a one server, right? And that server has the IP addresses 2.0.0.0. Okay, /8 information. I'm just giving the disadvantage of the static route. Why we are not going to prefer the static on the market right now. So for example, R1 has a connectivity with the R2, ISP, and this my link has the IP addresses 12.1 and 12.2. This my link is 12.1 and this is the link is 12.2. Perfect. And I give the one static route towards the server. I said IP route 12.2. So we have defined the route, and after defining this route, what happened? The router is going to maintain this routing table. Perfect. Now, if any packet is coming to me, for example, the router is going to generate a packet. The packet has a source 12.1 and the destination is 2.2.2.2.2. The packet is coming to me. ISP will forward the packet to this guy. Thus, we have a communication right now. But this is the server that is purchasing the service. This is the router is purchasing in my location of Delhi, and this server is present in some other location. Maybe this is a Facebook server, right? and this server is present in the California location, right? So what happened if server, that is the Facebook company, that maybe this guy had changed the IP address of this guy, right? May have changed the network ID of this guy and make this 3.0.0. So can I ping this guy? No, I will not able to ping because now network ID is 3.0.0.0. And will the Facebook server will going to inform us? No, he will not going to inform us, right? It is something like that. Whenever this guy name is A and this guy name is B, so you have a number of B number, the B has a number of phone number 123 and this guy has a 456. So in the phone book of A, he has a number of B is associated with the 456. So they can make a call, right? They can make, sorry, 123. So they can easily make a call to the B because they have a number in the phone book. But what happened if this guy has lose this number and change this number, make it say that 789? Can I make this call to this guy? Not, because this is the static thing. The static things I have defined over there, right? These are the static things in the phone book. I have said my number, this guy number. So if this guy lose this information and maybe the phone, he has lost the phone, and phone was the 123 previously, and I have a number in my phone book 123. But what happened? He's lost this phone and this number has changed. Now it becomes the 79. Can I make a call to this guy? Not. Same thing happened, right, on this guy. If this number has, if this network had a change, you don't have any awareness of this guy, and you are still sending a traffic to this network, and all the traffic will be dropped on the ISP side. This is the biggest disadvantage of the static route. Once you define it, it will present in your routing table, even the route exists or not. So the first of all, your unwanted sharing of sending the information to this guy and wastage of memory of the router. Tell me one thing, if this route is not exist on the internet, if the route is not exist on the internet, why should I maintain this route in my routing table? Why should I maintain this route in my routing table? Taking the process and memory as well as if the route is not exist, right? And the biggest disadvantage, right, if anything has changed over there, no one is going to inform me, right? This is the biggest disadvantage of the static route. So to avoid this problem, what we have, but the good thing about the static route, they will consume the very less CPU. Let me write on this thing. Dynamic routing. This is a very good advantage of them. If you have a very less amount of router, for example, if you have 3-4 routers, you can implement the static route. You can implement that. That is a very good thing because they will take the very less CPU. But if you have a 20 routers in your network, it's not possible to configure the static route. Maybe you on R1 router, you're going to configure the static route over there, and you have configured the 50 routes. On a 50 routes on R2, 50 routes on R3, 50 routes on R4, 50 routes on R5, 50 routes on R6, 50 routes on R7. But somehow you forget some routes and you have misconfigured the 49 routes on a R8 router. What happens? Still you don't have one information on the R8 router because you are doing all those things manually. You whatever the static router we have we have a 50 static routes over there, and every router you are going to do manually, right? But for example, what happened? You have missed one static router on a R8 router. The packet is coming for this network, and the network has a 1.1 is source and destination 8.8.8, and this 8.8 is not available on this router. The packet will be dropped. So the problem with the static router is first of all, if something has changed, no one has going to inform me. Another thing, if this route is not exist on the ISP, still this route is present in my routing table. They will consume some memory. This is not suitable if you have a large network. This is not if you have a large network. But the good thing about it will take a less CPU process as compared to the dynamic routing protocol. And this is the reason why we are preferring the dynamic routing protocol in the market. Because in a dynamic, what happened? What I told you, the dynamics mode. If you lose this information, please inform me. I will remove this route from the routing table. So let's see how the dynamic works first of all. Then we'll discuss what are the dynamic routing protocols we have. So before I'm going to start the dynamic routing protocols, guys, I'll just let you know, I'll just give the one story to all of you. This is the A, this is the B, this is C, and this is D, right? and this is E. Just take a 5 example, that's fine enough for that. And there is a one guy over there. The guy name is Upasana. The girl name is Upasana, right? When the Upasana comes in the classroom is X, right? When this Upasana knows only to the A, right? Upasana only know to the A. The once Upasana comes in the classroom, so Upasana know the A. What A will do is introducing Upasana to the B. A is saying to the B, hey B, this is Upasana, right? What B will say that B is going to inform to the C, hey B, Upasana is my friend. C is going to inform to the D, Upasana is my friend, and D is going to inform to the E, Upasana is my friend. This is how every guy is going to share the information to the this guy. Every guy is going to share the information to this guy. So whenever new things is coming in a network, right? Whenever new things is coming in a network, A has to inform to the B, B has to inform to the C has to inform to the D, and D has to be informed to the E. And this is a way what happened. E has a knowledge about Upasana. For example, the another girl is coming, Anika is there, right? And this girl coming in the classroom, what happened? A is going to inform to the B is going to inform the C is going to inform the D, and D is going to inform to the E. Now A, B, C, D, E all have a complete information about this guy. Seem like a dynamic routing protocol box, guys. Let me do one thing. I'll just make the router number 1, this guy, and this is my router number 1. This is my router number 2, and this is my router number 3. Perfect. And we have a one LAN network behind the R1. This is my R1 router. This is my R2 router, and this is my R3 router, and we have information behind the this interface information 12.1. This is the information of the router, guys. 12.1 is this is the IP address, or we can say this is the information of this router. 12.2, 23.2, and 23.3. Okay. Now we have a LAN information behind the R1, that is my LAN network 1.0.0.0/8 classful information. We have a LAN information of the 2.0.0.0/8, and we have a 3.0.0 information /8 over there. So far is good. Now, as we know that by default on every router we have this command is enabled, right? IP routing. What is the use of this command? It enable the unicast routing, right? But not multicast. Remember this thing. It only enables the unicast routing. If I'm going to disable this command, what happens? The router will behave like a host, or we can say that PC. If I'm going to, by default this command is enabled, right? So if you are not going to enable this command, what happened? You are not going to implement the router ESGRP or any routing protocols. If I say the router ESGRP 1 and no IP routing command is enabled on the router, they will give the error message. Error saying that first configure IP routing. Okay. So now I'll just take example. What's happening? Let me copy this thing. X. Okay. So by default, IP routing command is enabled, and each router is going to maintain the routing table, right, based on the network ID. So this is my 0/1, this is my 0/0, and this is my loopback number 1. Loopback is a treat like a one broadcast domain. Also loopback number 1 on this guy, and this is also loopback number 1. So we can create a multiple loopback. Loopback is a virtual IP address, does a virtual interface that does not have any MAC address. So what will be the routing table of R1, guys? For example, the routing table R1 is 192.168.12.0. That is associated with the 0/0 interface, right? Connected 1.0.0.0, and we have a loopback number 1. Copy. Perfect. Loopback number 2. This C is going to represent the connected information, and connected has a AD and matrix is 0. This is my connected information of this guy. This will be the 23.0, and this will be a 3.0, and we have one more route on R2 because we have another connected route, that is a 191.23.0, that has also 0/1. This is my by default routing table of routers, right? Let's see what happened if I'm going to enable any dynamic routing protocols. For example, just as you know, we have a one dynamic routing protocols. I'm just going to discuss how the dynamic is working, right? What is the meaning of dynamic? I'm just going to tell about the dynamic routing. I'm just going to use the X. Okay, this is the one routing protocol. So I'm going to enable the X over there, X over there, and X over there. After the enabling X, what happened? R1 is going to inform to the R2, hey dude, I have something for you. I have some information for you. And in this information, what this guy will say? This guy will say the information about 1.0 information /8 and 12.0 information /24. This interface, right? We have a network ID of this guy /24, and we have a network ID of this guy /24. Right? So R1 is going to share this information, 1.0 information, this LAN network, and the 12.0 information. This information R1 is going to share to the R2. When R2 will receive this information after the enabling the X protocol, right? After the enabling the X protocol, I'm just letting you know what is the meaning of dynamic, right? After the enabling X protocol, R2 will receive the one update. In this update, what information is there? The information is 1.0 and /24 or 12.0/24. What R2 is saying that let me check whatever the information I have. I already have a 12.0 information that has a best route because this is the connected. Okay, that is the best route. This is directly connected because I'm learning this information, right? So I'm learning this information. Of course, we have some AD value of this guy. So maybe X has a AD is 20, not 20, 21 make it. And this guy has a by default connected has a AD is 1, sorry, 0. So of course I have a one best route because AD 0 is more paper, right? Lower is more paper. So R2 only accept this route, right? I mean, it's not going to accept this route. So R2 just discard this information, but he said that I can, okay, I don't have a, R2 is going to tell this guy, I don't have information about the 1.0 subnet. I'm going to install this information. So this is the guy that is going to maintain the X, that is the name of this protocol, 1.0.0. And I'm learning this route that has a ED is 20. Okay, some metric will be there because dynamic route has a metric. And this I'm learning this 12.1, and I'm learning this route from the 0/0 interface. Sorry, on 0/0 interface. I'm learning this route on this interface, right? And the next stop will be 12.1 because I'm getting this update from the my neighbor 12.1. And this is the route. This is the name of this guy protocol, and this is the AD of this guy that has a 21 and some metric. I'll let you know what is the meaning of metric. Okay. Now R2 will receive this information. What R2 will do now? R2 is going to inform to the R1, I have something also for you. Do you want this guy? He said, okay, sir, please send me the whatever the information you have. This guy is sending the own information, this information 12.0/24, then 23.0/24, and then 2.0/24. Sorry, /8. R1 will accept this update. He said that, okay, I already have a best information that is my 12.0 information. So I will not accept this guy. Hello. Yeah, tell me, Balaji, I'm having class. Just tell me what happened. Cisco has like cancel all the exams, right? Yeah, Cisco has all cancel all the labs. R3 will send this information to the R2. Once I lose this information, what R3 will do? R3 will first remove this route from the local routing table, inform to the R neighbor. He will remove this route from the routing table. This guy also remove. R2 is going to inform to the R1, remove this route from the routing table. Clear? For example, if I'm receiving one route 4.0 from the neighbor, R3 is going to inform to the R2. First, it will install this information. Then R3 is going to inform to the R2, add this route, add this route. This is how whenever the new guy is coming in your classroom and whenever the guy is exiting from your classroom, it always update their table. This is how your dynamic routing protocols works, guys. Clear now? So for example, if any packet is coming for me, for example, if I want to provide the communication between this LAN to this LAN. That is some location there. This is Delhi. This is the Bangalore. And this is the Chennai, right? So we can assume that this is my ISV over there. Okay. So if I want to provide the communication between this LAN to this LAN, what happened? I will create a packet, right? And this packet has a source 1.1.1.1.1, and that has a destination 3.3.3.3.3, right? And this packet is coming whenever any packet is coming to me on the router. What router will do? It will look up the routing table. Do we have a information about this network? According to the routing table, he said, yes, I have that information. I need to forward the packet to whom? 12 or 2. From which interface? Packet comes to the R2. R2 will look up the routing table. Do we have information? Yes. Forward the packet to the 23 or 2. From which interface? Do we have information? Forward the packet to the loopback number 1. This is the request packet is coming. Reply will generate. In the reply via source. Source will become the destination. Destination will become the source. Source and destination. The packet is coming to me. The reply packet. This is a reply. That was a request, right? So it is something like whenever you are going to request your Google Chrome, what happened? You are sending your traffic. You are sending the request to the Google server, right? And then the Google page will come on your system. So the reply is coming to this guy. The R3 will look up the routing table. Do we have information? Yes. Forward the packet to 23 or 2. Wait from this interface. Forward the packet to the. Forward the packet to the. This is how the communication will happen in the dynamic routing protocol, guys. So far is good. Anyone has a question? Okay. So let's come back to the chain. So if I'm talking about the dynamic routing protocols, we have in a dynamic routing protocols. So everyone has clear with the dynamic. Everyone is clear with the routing. Routing is a mechanism that feeds the remote route into the local routing table. What is the protocol? Protocol. Protocol. I say that set up rules. What is the meaning of rules? Set up. What is the meaning of protocol? So just make a simple A, B. This guy is from China, not China in these days. This guy from the India, and this guy from the London, right? So this guy know the Hindi actually, and this guy know the French, right? But I'm trying to say that can they communicate? Not, right? Because the language of this guy is Hindi, the language of this guy is French. They cannot communicate. So what we have to do, we need to perform the rules over there. We need to make the rules over there. I say that okay, if you want to provide the communication between this guy and this guy, you just need to learn the language that is in the English, right? English is the protocol or rules. We can say that. So if you know the English, then we can communicate. Otherwise, we cannot communicate. Same thing happened with the router. If you want to, for example, of the rules of that, if you want to attend this training, you have to come the 8 o'clock, right? Then you can attend that. This is the rules of this training classroom, right? Same thing. If R1 is running with the X protocol, you have to be run the X protocol over there. For example, you are going to run the Y protocol over there, not X. What happened? The communication will not happen. You are making violating the rules over there. Rules should be same, right? If you're running the X, should be X. If you're running the Y, should be Y. Clear? So dynamic routing protocols has two types. The first of all, it has a IGP. and another has a EGP. IGP stand for Interior Gateway Routing Protocol. EGP stand for Exterior Gateway Routing Protocol. Right? Now, as the name suggests that it's an interior, right? As the name says, it's an interior. Interior means what? First of all, interior means under the home, or we can say under the company. Exterior means what?
Outside the home.
Between the home and between the company. So, for example, this is my one home. We can say one company, and in this company, we have some routers R1, R2, R3, R4, R5, R6. If you want to provide the communication within this LAN to the this LAN, we have to use the any IGP protocol. For example, I can go for the OSPF, I can go for the RIP, I can go for the IGRP, I can go for the EIGRP, I can go for the ISS protocol as well. You can go for the any one of the protocol. It's totally up to you guys, right? Under the this is the IGP protocol, right? Seem like we have another home, or we get the another company, router 1, router number 2, router number 3, router number 4. So between this LAN to the this LAN, we are going to use any protocol. So just take example, I'm going to use the EIGRP over there and OSPF over there. Okay. So in the EGP, we have a single protocol that is known as a BGP, a border gateway protocol. So we are running with the OSPF under the company network. We are running the EIGRP under the company network. But if you want to provide the communication between these two guys, we have to run the BGP. That's the meaning of exterior. BGP means border gateway. Border means what? Between these two company border. So we are going to run the border gateway protocol. That's my BGP, right? So first we have to go, what is IGP, right? And how does IGP works? Because first you have to make a communication under the company network. Then you are going to learn about how to make a communication between the two different company, right? So first we'll go through the IGP, then we'll go for the dynamic routing protocols. Even in the IGP, what happened? Even in the IGP, in a IGP, what happened? We have a two flavor. That one is the distance vector routing protocol. Just write. I don't have a space over that, so I didn't write it. So just write on this thing, and let me make a space somewhere. I'll make some space over there. Let me do it. Okay, come on. Okay, so I'll make it change over there. Let me remove this guy, and I'll say that. So right now, I'll just remove this guy. Even in the IGP protocol, we have a first protocol is known as the distance vector routing protocol. Distance vector routing protocol, and another is a link state routing protocol. So in a distance vector routing protocol, we have two protocols. The first of all, we have a not two, we have three protocols. And in this link state, we have two protocol. The first one is the distance vector is known as the RIP. We have a RIP in the two version 1, version 2. Then we have a IGRP. So we are not discussing much more of the IGRP, but just have a basic difference. And then we go for the EIGRP. Okay, in the link state, we have a OSPF and we have a ISS protocol. Okay, so this is my, let me talk about the, so hope so these two words are clear to all of you guys. What is the meaning of this word? All the time, what is the meaning of this routing protocol, dynamic routing? All these words are clear to you. And this one is also IGP clear to you under the company network, EGP and between the company. Now let me tell you the what is the distance factor and the link state routing protocol. Let me have a basic difference. See, distance factor, as the name suggests, that we are going to forward the packet based on the distance. That's it. For example, if we have a router 1, router 2, router number 3, router 4, and we have a behind the server out there, and this guy has a connectivity with this guy. If I'm going to implement the, for example, this guy has a link is 10 Mbps, this guy's a link is 10 Mbps, this guy's a link is 10 Mbps, this guy's a link is even this guy has a link is 1 Mbps, right? And if this guy's a link is 1 Mbps, if I'm going to implement the distance, what happened? I always prefer the lower distance. I always see, if I go from the R1 to R2, then R3, then server, right? If I'm going for the R1 to the server, what happened? The distance is, for example, the just I assume that as a kilometer, right? The 1 kilometer from there, 1 kilometer from there, and 1 kilometer from there. So it will be a 3 kilometers. 1 kilometer from there and 1 kilometer from there. It will be a 2 kilometer. I always prefer the 2 kilometer lower distance. I always prefer the lower distance. Doesn't matter what is the bandwidth of this link. Doesn't matter what is the bandwidth of this. That is the distance vectoring protocol. In the link statements, what happened? I never go for this guy. I always go for the best bandwidth. I always prefer this guy who has the best bandwidth. That's a link statement. This is the basic difference I'll just give you right now. What's the overview of this thing, right? So in a distance, we are going to RIP one. So first we have to go through the RIP protocol, then we'll go for the next one. Okay. So today we are going to start the RIP. Hope so this basic things to clear all of you guys. So what is the meaning of routing, then what is the meaning of dynamic routing protocol, IGP, EGP, and distance vector. So let's talk about the RIP. So write down some information about RIP. RIP, first of all, it's a stand for routing information protocol. So hope so this two routing is clear. What is the meaning of routing? Routing is the fetching the route from the remote routing table from the local routing table. So putting this route in the local routing table. Fetch the route from the remote site into the local routing table. Information means what? What I told you, that a router has the information, right? A router keeps the information, and the information is known as the
routing table
or the network ID. That is my information. For example, this is my R1 router, this is my R2 router, and this is my 12.1, and this is my 12.2. So this is my information. This is my information. This is my information. If you have a 2.0 subnet, this is my information. This is my information. So what is the meaning of the routing information protocol? Protocol means a set of rules. It means that if you're going to implement the RIP over there, you have to implement the RIP over there. Okay. If you're going to implement the RIP over there, you have to implement the RIP on this side. Now, what is the meaning of routing information protocol? R1 is going to share the this information about the own this guy, and R2 is going to share the information about this guy. Okay. So now next thing, it works on the, come on man. Next thing, it works RIP works on UDP protocol, and that has port number 520, both source and destination. Okay. DP is a layer 7 protocol. Then we have another thing. RIP has a 2 version that we'll discuss what is the version. version 1 and version 2. Okay, now another thing, rip send update at every 30 seconds, and this update is known as periodic update. What is the meaning of this one? So hope so this thing is clear. UDP is a UDP protocol. UDP is what? It's a user datagram protocol. So whenever the RIP packet will be sent or any update will be sent, it will encapsulate with your UDP packet, right? Encapsulation means what? The first of all, encapsulation, I can say that this is my phone, right? This is my phone. I purchased this phone for someone. So this phone is present in the Bangalore location. I need to send this phone and give someone to the Delhi location, right? This is my Delhi location. I need to give this phone to the Delhi location. What we have to do? I cannot send directly to the this, like this is my I need to this is my post office, right? Or any courier service. This is my courier service over there. So I cannot give this phone to the courier service and say that hey, just post this phone to the Delhi location. I need to cover these things with some parcel, right? So this is known as the encapsulation. Encapsulation is covering something. So whatever the UDP updates we have, sorry, whatever the RIP updates we have. So this is my RIP protocol. RIP has the information 1.0.0.0. This information will be encapsulated with the another header that is known as UDP. The UDP is a protocol that is going to encapsulate the RIP information. That is a minimum encapsulation. So whatever the packets we have, whatever the updates we have in the RIP, it will say to the encapsulate with the UDP protocol. Clear? Now, as said, RIP is a layer 7 protocol. It has a two versions that we'll discuss what are the version 1 and version 2 we have. Then RIP send at every RIP send update at every 30 seconds, and this update is known as a periodic update. Now, periodic update means what? For example, R1, R2. There's a two routers over there, R1 and R2, and R1 is saying that this 1.0.0.0.0/8 information, and we are going to run the RIP over there. Do you know what happened? And 2.0 also is there behind the R1. 2.0 is also present behind the not R2. So R1 is going to first save the update to the R2, right? And in this information, we have a 1.0 and 2.0 information. R2 will install this information and RIP routing protocol, RIP 1.0.0, and they have some edit that limit right now, and the 2.0.0. You know what happened? This update I had sent. Okay, now after the sending update, you know this thing will happen look like this. Then 29, 30 is completed, right? 29, 28, 27, 26, 25, then 20, 15, 10, 9, 8, 5, 4, 3, 2, 1. I'll send the next update. Then same update 30, sorry 30, 25, 20, 15, 14, 10, 5, 4, 3, 2, 1. I'll send the next update of this guy. So every time I'm going to send the same information. Every time I'm going to extend the complete routing information to the art. Every time I'm going to extend, I'll show you that thing, don't worry. We'll see the each and everything in the practical, right? So every time R1 is going to share the complete information to the R2, complete information to the R2, and complete information to R2. This is known as the periodic update. Periodic means what? At every cycle, right? At every cycle, I will say the complete information. So we can see that we will send complete routing information in update packet. Now, next thing, RIF has a 80 120 by default. By default means what? Whenever I mention the word by default means we can change it. It's totally up to you as the network engineer is going to manipulate this thing. Okay, Now one more thing, let me share you this thing, just a minute. Okay. Mm. Yeah, let's write down this thing, is very important. Let me remove this guy. What I'm trying to say that I'm trying to say this thing. If you have a R1 router, if you have a R2 router, and you have a information of 1.0, 2.0, 3.0, and till 25.0, then 26.0, then 27.0, and then 28.0. So how many R1, how many update packets? So of course we are running with the RIP over there. How many update packet R1 will send at every 30 seconds? Because a single update, this is my update packet that will encapsulate with the UDP header, source port and destination port will be there. So in this UDP packet, you know, at the time we will have a 25 dots. So in the first 25 dots will be sent in the first packet, and second packet will say the next information, rest of the information, 26, 27, and 28. This is second update packet. It means that if you have a 28 route, listen to me, if you have a 28 routes behind the R1, if you have a 28 routes behind the R1, R1 is going to use a 2 update packet at every 30 seconds, a periodic update, right? And they will say the complete routing information at every 30 seconds. They will put the complete routing information, 2 packets. Just compare with the 1000. How many update I'm going to send? If you just calculate it, if you have
400.
how much? 1000 divided by 25, right? 40.
40.
Man, can you imagine that? 1000 routing information is not a big deal. 1000 routes is not a big deal in the dynamic routing. We can have it, right? We can have the 1000 routing information, the dynamic routing protocol. But can you imagine that if you have just have 1000 route in a 30 second, in just a 30 second, you are going to send the 40 packets, right? It's not a good thing, right? So this is the just write on this thing at in every update packet, they can contain up to 25 routes, right? Then RIP has a metric. Okay. Not we can say revenue like this. Whenever RIP send any update to the neighbor router, not neighbor router, to the RIP router, it will send some extra information, and that extra information known as metric of RIP, that is called as hook content. In a RIP, max hook count is 50. 16 hook count will become unreachable. What I'm trying to say that, for example, it means that you can only put the 15 routers. One hook count, you can compare the one hook count. One hook count is equal to one router. Okay, one hook count is equal to one router, meaning R1, as I told you that this is the distance factor available. R1, R2, R3, R4. I say that whenever the router is going to send any update to the R2, it adds some extra information. That extra information is known as a metric update. So R1 is going to share this information to the R2, 1 or 0 or 0 or 0 information. One hook count is equal to one router. In the R2 routing table, we have some update 1 or 0 or 0 or 0 that has a 80 is 120 by default, as I discussed this thing, right? Then we have a metric is 1 because I pass this information to the one router. On this interface, the metric is 1, right? Whenever I pass this information, R3, 1 or 0 or 0 or information with the 120 80, the metric will become the 2 now. Whenever R3 is going to pass this information to the R4, R4 has the information 1 or 0 or 0 or 0, 120 80, and the metric is 3. So every router is going to exchange the add the hop count over there. So can you imagine it from the R1 perspective, how many routers are there? R2, R3, and R4. Because on this interface, I'm receiving the update, right? So I have a 3 hop count, or we can say the 3 metric is there. 3 hop count, 3 router, 3 metric. It's simple. So if you have a 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Can I provide the communication between this line to the this line? This line to the this line? No, it will not. Because the maximum hook count is 15. 16 will become the unreachable of this thing.
Unreachable.
Right? So you cannot provide the communication. You cannot put the more than 15 routers over there. In your network, if you're enabling with the RIP protocol, you cannot put the more than 15 routers. Okay, so this one is also clear, I think so. Okay, we'll see this thing each and every project. Don't worry about that, right? Next thing. Okay, it's a distance vector protocol. So as we know that it's a distance. Now, distance means you know the what is the meaning of distance is that is going to represent the hook count. What is the meaning of vector?
Sir, one question.
Yeah, tell me.
Hop count.
Yeah.
We are saying that if it is connected serial wise, 15 hop count, right?
Yeah.
Its maximum supports. What happens if it is connected hub and spoke topology more
How
than 50?
So Harvest also will happen look like same thing in the Harvest book technology. If you're going to implement, for example, if I'm going to implement a DM VPN, right, that will also become the Harvest book. So here, for example, this is my R1 router, R2, and this is my ISP over there. Okay, this is my R2 and this is my R3, right? So this is the hub and a spoke, right? We can create a tunnel between this guy. So I can assume this guy is the hub and this is the spoke router. So also same thing happened, right? When R2 is going to send the update, it will send the update through the tunnel, right? It will send the update. This is the 2.0 or 0 update. It's sent with the through the tunnel. So R1 will receive how many of hope count from it? This is a single hope count, right? So R1 will have this information 2.0 or 0 or 0 update as a 120 is 80 and metric is 1 only. So they can receive it. And R1 can share this information to the R3. So R3 will receive this information as a 1, 2 or 0 or 0 or 0 or 0 as a 120 and metric is 2.
So in hub and spoke, we can connect more than 15 route.
Yeah, we can connect it.
Okay.
If you are connecting with it through the tunnel, right? Of course, you are going to run with the through the tunnel. That is the DM because frame relay we are not going to use, and That was hub and spoke. That frame we are not going to use in the market. So we have one offset that is a DMP pin, or either you can create the GRE of there. Is anything. So you can have a more than 15 hours. You cannot connect more than 15 hours, but you can have this one. Okay. Now we have a, I'm talking the vector, right? So the hope, for example, this is the raw server behind the 4.0 of this network. So R1 is getting the 4.0.0.0. These are the hope on one. These are hope one. This is hope on one. This is hope on one. This is hope on one. So R1 will get this update from the R4. So distance is just going to remember what is the hope on, right? What is the distance from the source to destination? That is going to remain the distance, right? What is the hope on from source to destination? Vector means what? Next hop. Vector is just going to use the next hop. What will be my next hop and what will be my exit interface? We're trying, see, whenever I'm going to send any packet, when I say the ping 4.4.4.4.4, packet comes to me on the router on which this interface they will packet receive, right? On the ingress interface, the packet will receive from which interface I will forward the packet. I can have a two gate, right? I can have a two gate 1 and gate number 2. Which interface I will use to forward the packet? So that is defined by the next hop, and that is going to represent the vector. Vector is just going to represent the next hop. So 4.0.0, I'm receiving this update from which way? R4. I will use this next hop. That is my vector. As you know, the routing is routing, protocol is protocol. Routing is fetch that remote information into the local routing protocol. So local routing table. Protocol means of setup pools. Okay, the next thing we have. Okay, anything else in the theory part? Okay, it prevent the loop, not prevent drift, uses split horizon to prevent loop. So everyone knows the what is the meaning of loop, right? Loop is something like that. Now if R1, for example, if R1 is there, R2 is there, right? R1 has some information 1.0.0.0/8, and this meant 12.1 information 12.1 prefix, and so 12.2, right? So R1, this is the interface 0/0, this is the interface 0/1. So R1 will send this update to the R2. R2 will receive this information on which interface? 0/1. So R2 will first maintain the routing table. See that 1.0.0.0. 1 is a hop count, sorry, and the 12.1 is the next hop, and I'm receiving this interface 0/1. What R2 will do? R2 will forward this information to the 0/0, right, to the next order, and R2 will also forward this information to the R1. So if R1 will receive this information, what R1 will do? R1 is receiving this information on which interface? 0/0. It will forward the information to the next guy. If we have another router, at the same time, it will forward the information to this guy. Same look like this, same look like this, same look like this, same look like this. So it's creating a loop over there, right? Same information is moving from across the network. Same information is moving across the network. This is the loop. So what I said, that it uses the split horizon rule to prevent the loop. And what a split horizon is saying that whenever I'm receiving, let me do one thing. I'm present on R1 router, R2 router. Whenever I'm receiving any RIP update, I will forward that update each and every interface except CV. So R2 will forward this update to the R3, but never it will send this update to the 0/1 because of by default a split horizon rule is enabled on this interface because of the split horizon rule. So don't worry, I'll show you. I'll make the loop as well as, don't worry, I'll show you the how the split horizon is working as well as. I'm just giving the overview right now so that you will become the familiar with this word. So split horizon means what? Split horizon is whenever I'm receiving any info deep update, I'm receiving any deep update on which interface 0/1. I will forward that update to each and every interface. This interface, this interface, this interface, except from I'm receiving. I will never send this update to the 0/1. This is the way I'm going to prevent the loop. This is known as a split horizon rule. And by default, it's enabled. By default, the split horizon rule is enabled on the router. Next thing, we have a so far is good. And one more thing is there. Let me write on the difference in the version one. Version one, it sent the bit on broadcast address. It does not support. I'll let you know what is the meaning of each and everything. Don't worry. It does not support authentication. It does not support summarization. It does not send any subnet mask information in update packet. Next thing, that's enough information there. Version 2, it sent the update on 24009 multicast address. It does not support, sorry, it does support authentication. Authentication can have a text format, that is we can say clear text and MD5. It does support summarization. It does send, that's a very important point, it does send submit mask information in update packet. And because of this reason, it is classless. And this is, it is class full. Exactly right. So it's a class full, right? Because of this reason, this is the classless, right? Now, one more thing is there. I forget. Okay, classless, class full, class. Write on this thing is a note. Classless has introduced in 1993. So you can imagine that whatever the classful routing protocol, whatever the classful, if I'm talking about the version 1, EHRP version 0 and IGRP protocol, even the BGP version 1, 2, and 3, all this classful routing protocol has introduced in the before the 1993. Yeah, version 2 does support the classful. Is support version 2 support the classful. Anything. Okay, so classless has introduced in the 90 before the 1993. Whatever the protocol has came, they all are the classful. All are the. So if I'm going to talk about the EHRP version 2, that is the classless. RIP version 2, that is classless. BG, OSP of BGP version 4, these all are protocol now are came after the 1993. Okay. Now the first about it sent the update on the broadcast. So why we are not going to use the version 1? Why we haven't used the version? What is the disadvantage of this thing? Broadcast. Guys, have a look. I set up broadcast. Okay, fine. For example, router number 1, switch 1, router number 2, and this guy has a server. This guy has an end user, and this guy has 100 PCs. 100 ports are there. 100 PC. Now, if R1 will send an update packet, if R1 has information 1 or 0 or 0, and we are running with the RIP over there, and we are running with the RIP over there between R1 and R2, right? So of course, server is the end device, PC is the end device, and 100 PC also there. That is a printer, PC, that is the end device, right? Now R1 will create a one update packet, right? In this update packet, for example, we have a source MAC is A, destination MAC is B. So then we have a type 0x0800 IP. Then we have a source IP is 1.1. For example, this guy is 1.1. Destination IP is broadcast, right? Of course, destination MAC is also broadcast. Sorry, MAC also is broadcast, right? And then after that, we have a UDP, 5 source port 520, destination 520, 520, and 520. Then we have a RIP information. In there is RIP information. We have update 1 or 0. This is the packet look like this, right? This packet comes to the switch 1. What switch 1 will do now? Switch 1 is the broadcast packet. Okay, let me flood this packet to the each and every interface. Can you imagine that if you have a 100 PC, if you have a 100 PC, all 100 PC can receive this information, right? And if this switches has a connectivity of different switches, switch 2, and this switches 2 has a different connectivity to the switch 3, and this switch 3 has a connectivity to the switch 4. And whatever the LAN user of the switch 2, whatever the LAN guy has the switch 3, whatever the LAN guy has a switch 4, all they will receive this update. This update was only for which guy? R2. Who is receiving this update? Each and every interface is receiving this update. So what is the problem of this guy? You got totally wastage of the bandwidth of this link process, wastage of the bandwidth of the link process. Is there any guy over there? Is there any guy over there? Is there any guy over there that has a RIP? No. Why should I send this update to this guy, and this guy, and this guy? Even why should I entertain the packet? Why should I entertain this packet? So this is the problem, right, of the broadcast. As compared to the in the multicast, what happened? This is the problem that have overcome in the version 2. The multicast, what happened? Multicast is what? Oh, WhatsApp group is a very good example of the multicast. Instead of sending the message to the each and every contacts, we are sending the message to whom? Make a group of this guy. And in the group, we have 5 people. We are sending the message only to 5 people. So if I'm going to run with a version 2 and version 2 over there, अरे इसको चेंज कर दिया, कोई दिक्कत नहीं है, हो जाएगा, पास हो जाओगे आप। मैं आपको कॉल करता हूँ थोड़ी देर में। जयपुर का माहौल कैसा है? बस जयपुर, आप जयपुर में रहो। अभी आने की जरूरत नहीं है। हैदराबाद आ गए तो मैं आपको कॉल करता हूँ थोड़ी देर में, रुको, मैं बैच ले रहा हूँ, कॉल करता हूँ। Okay, so if I'm going to run the version 2 and version 2, what happened by default, once you enable the router and router 2, they will join a one group, right? And the group name is, I'll let you know, I'll prove this thing, each and everything, right? They will join the group as well. As in this group, we have R1 and we have R2. Only two routers are there, no links are there, only these 2 routers are there, these 2 people. So whenever this guy will send an update, now the information will change from there. Information will change from there, right? Now we have a multicast MAC and we have a multicast address. Now packets come to the switch. Switch will only forward the packet to whom? This router will only forward the packet. The switch will only forward the packet to this guy. And in this guy, only the R2 will receive this information, not this guy, not this guy, not this guy, not even this guy, not even this guy, not even this guy. This is the benefit of having the multicasting. Okay, we'll learn the multicasting as well as how the multicasting is working. In the multicast IP multicast, we'll see this thing, don't worry. Then after that, support does not support authentication. Guys, how can I believe this guy? This is a genuine guy or not? Maybe this is the fraud, maybe this is the hacker. How can I receive? If I'm going to share this information to the R2, how can I believe this guy is a genuine or not? So authentication is what? I'm just authenticate the user. Is this user is correct or not? Authentication is just the meaning of that. So this is the authentication that does not support summarization. It supports the authentication. We'll discuss the summarization in very much detail in the EIGRP part. Okay. So it does not support summarization. Summarization in this method, we can reduce the size of routing table. We can reduce the size of routing table. Okay. Then it does not send the subnet mask information in the update packet. What is the meaning of that? /8, if version 1 update packet look like this, if version 2 update packet look like this, and because of this reason it is classless. What is the meaning of classless? If you have a 2.0 subnet 2.2.2.2/24, if you're going to implement the version 1, the version 1 update packet look like this. 2.0.0.0. So what R2 will assume that, is there any subnet masking information over there? No. What R2 will assume that, okay, this is the class, this is a 2.0.0 subnet. Okay, it means a class A IP address. I'll mention that 2.0.0.0 slash it. If you are not sending a subnet mask information based on the first octet, that is belong from the class A, I will assume that this is a class A IP address. I'll make the slash 8 over there. But whereas in the class, in the version 2, what happened? The update will look like this. So based on that, R2 will maintain the routing table 2.0.2.2.2/24. So this is the classless over there. So this is the difference. This is the basic information about the RIP, guys, that we have discussed in the today class and the theory. So if you have any questions regarding how does the routing works and whatever the use of this each and everything, you can ask me now. If you have any questions, because practical we can't show you today. Tomorrow we'll do the practical of this thing. And guys, please make a one group of the WhatsApp. Is it possible? Otherwise, you just do one thing. Just ping me on the my number. I'll add you in some group. Okay. Don't create a group. I'll add you in some group. Okay. Because it's otherwise we can create a group. It's totally up to you. Because if I need to share some information, then I can put that information in that group, right? Maybe in this weekend now, maybe on the Thursday we don't have a class, so I'll have to inform over there, right? Maybe, I'm not sure. Maybe I'm just saying that I have to go somewhere. Clear? So anyone has a questions? Hi Chandrasekhar, you are spending your time with the technology.
Yeah, bro. Actually, I have one question on EIGRP.
Yeah,
Some of the book I have seen it is a advanced distance vector, and some of I have seen hybrid protocol.
yeah.
So, what is the different?
So tell me one thing. Why I'm saying the hybrid? Hybrid means what? Is a combination of the link state routing protocol and the distance vector routing protocol. So what is the meaning of distance vector routing protocol? It always forward the packet to based on whom? Distance, right? So if I'm going to implement the same topology, as we know, the link state means what? It will forward the packet based on the bandwidth. Okay, and distance means what? It will forward the packet based on distance. That is the whole point. 20 Mbps, 20 Mbps, 20 Mbps, and this is the 1 Mbps. EIGRP. If I'm talking about RIP always use this guy, right? Lower hop point. It will never choose the bandwidth, right? It will always choose the it will always choose the lower hop point from this side. But in the hybrid, what happening? EIGRP is hybrid routing protocol, right? Hybrid is a combination of distance and link. It will never go by this link. It will always choose this guy. That's the difference in the hybrid. Clear?
Yeah.
Okay, guys. Then see you in tomorrow. I'll update this video in the just make the group. Otherwise, I can't update the video, right? I'll say the whatever the peoples are not there in the any group. So just ping me. Otherwise, you have to wait for some time. Whenever you need a video, just let me know, because after the 1 month, I'm just going to delete all the videos.
Can you give me your number? I don't have your number.
It's my 950 Ping me on this number. Done?
Yep. Thank you, sir.
Okay, thank you. Bye. Another way. Yeah, Chandrasekhar, I'll send. I forgot. I'll send you right now. Yeah, how get?
Thank you.